Welcome to part 2 of circuit network changes post-space age. This time I'll be covering the changes done to all factory buildings which don't strictly belong into the circuit network category. If you haven't seen the first part yet, consider watching it prior to this video, or if you're looking for just a specific section, may check out the chapters on the timeline and in the video description. Speaking of part 1, there are two small additions I want to add before heading to today's main topic. Number 1 is about the constant a decider combinator's output can be set to. Since version 2.0.36, released on the 26th of February this year, all constants can now be set to a number of your choice. For doing so, open up the decider combinator, navigate to the small pencil icon just to the right of the constant value, click on that icon, and type in your desired number. Special thanks to Atsuka for pointing out this feature in the comments under part 1. Now for number 2, I want to quickly talk about the programmable speaker. To be honest, I kinda forgot about it last time. The same Factorio update, version 2.0.36, also added a few minor features to our favorite noisemaker. Channel values are now able to control the volume of the sound the speaker plays. The acceptable range spans from 0 to 100. Values outside of that range, being smaller or larger, are clamped to the nearest acceptable one. Additionally, currently playing sounds can now be stopped the moment the condition returns false. Use the correlating checkmark box for enabling such. Lastly, the playback mode of all speakers received one new option called surface. You will be able to hear the speaker no matter the distance as long as you're standing on the same planet or space platform. Okay, that's all about part 1 add-ons. Finally coming to today's main topic, I'll set things off by starting with an elemental building to all automation, namely transport belts. Every belt, when connected to a circuit network, got equipped with a new read option called Hold All Belts. When selecting it, we can see yellow rails appearing on top of the other belts that are connected to our reading belts in both directions. Now, as you may guess from its name, placing items on those belts, regardless of the position, results in a signal that the reading belt will register and send out. In the past, similar behavior could be achieved by setting every belt to the existing hold option and then connecting all belts with red or green wires. This particular setup had a minor flaw though. Both undergrounds and splitters are not able to be wired to the circuit network, making it impossible to read items that are being transported on top of them. I am happy to inform you though that our new belt reading option does not suffer from a spoken drawback. Undergrounds, woven into the structure, and even splitters, shifting items left and right, are considered part of the belt array, thus making it possible to get their current contents from a connected belt reader. One thing to note here, each splitter belt counts as a separate lane, meaning the moment a splitter shifts an item to the other side, the signal of said item also shifts connected circuit networks. Additionally, a belt array does not stretch over the architecture that involves side loading, neither for merging nor for separating items. If you're curious about range limits, so far I honestly haven't found a maximum length for a single belt reader. Both insanely long belts stretching through many chunks, but also tightly packed belt snakes winding back and forth work just fine. With that said, let's have a quick glance at a practical usage for this new belt reading option. The structure that probably profits most from this new mechanic is the sushi belt, often used for science packs in labs or sometimes item mods before unlocking logistic bots. We can ditch the old memory cell setup and just wire every inserter, which drops items onto the belt to a belt reader. Say goodbye to other problems that feedback loops, wrongly wired inserters, and manual interference with the belt's content created. In cases where the sushi belt consists of more than one lane or has a lane balancer inside of the loop, set up one belt reader for every subsection of said sushi belt and wire all readers together to get an accurate reading of all items at any time. Alright, so far 2 transport belts. Let's move on to the next building on my list. In the first video, I talked about constant combinators being able to transport seemingly any signal to any other constant combinator on the map as long as both share the same logistic group. Well, this manual remote signal transfer can now be performed in an automated way too. Since 2.0, radars can be used to send signals over any distance as long as they have sufficient electric power. Here's how you do it. Start by placing down 2 radars in range of a power pole. Next, connect a wire color of choice to both. To see the signal transmission in action, a signal source and a signal receiver are required, but anything goes really. For this example, I'm gonna tell a belt to read passing contents and a display panel to show me any detected signals. When I now drop various stuff on the belts, the display panel will light up with corresponding signals as the items pass over the belt reader. Surprisingly, sending signals through radars does not introduce any latency. When we examine a bit further behind the scenes, both circuit networks are actually one and the same network. Be mindful though, a bespoken fact tells us that signal linkage is not unique to a pair of radars, meaning that every radar on the planet will be put into this very same circuit network. Essentially, you could imagine the whole mechanism working kinda like a giant global power pole that every circuit wire hooks into. Global is actually a good keyword, since despite promising you unlimited transmission range, different globes, or to be exact, different surfaces, do not mix signals with each other. Every planet, and also every individual space platform, gets their own global radar network. If you still want to separate signals for different transmissions on the same planet, additional logic is required. Such could be solved by compressing overlapping values into fewer channels through bit packing, or simply having a global clock signal telling signal entities to only send/receive content at a specific game tick. The implementation is entirely up to you though. Choose whatever fits your problem best. One more quick word about radars before I move on to the next topic. There's two separate power satisfaction thresholds to be aware of. The first one being the moment where radar successfully hooks into the global network. Said activity happens at 96% power satisfaction or more. Once connected, any minor variations in available power will not interrupt transmission immediately. Instead, power has to fall as low as 10% for the radar to lose contact to all others. Speaking in more practical terms, even if your base struggles momentarily to make enough electricity, remote signal transfer will not be interrupted unless everything powers down for good. When that happens, I'd recommend preparing some additional accumulators to kickstart just the radar for reconnecting after a blackout. As an alternative, placing down more power generating machinery will also get the job done. One of bespoken machines, and also the next building on my list, is the nuclear reactor. After years, we are finally able to attach wires to the heart of nuclear fission for reading out temperature and reactor content. By default, all reactors will use the T signal channel for temperature. If you prefer another, click on the signal slot to change it. One more detail to note here, fuel cells currently burning inside of the reactor will count as a full item signal. Generally speaking, this direct readout capability will eliminate the need for previously used steam storage logic. I was generally surprised when I tried to do the same to the counterpart to fission, the new fusion reactor, only to realize that said structure did not come equipped with circuit connectivity. I had to spend some time getting familiar with it before realizing that there's essentially no requirement for similar fuel management here. All fusion reactors will adjust their burn rate to the plasma demand dynamically. You know what other building doesn't have fuel management? This cylindrical shaped entity over here. The heating tower acts pretty similar to the nuclear reactor, in which it will continue to burn fuel even if the current temperature is already at maximum. This is good for getting rid of excess burnable materials such as wood, but may also waste energy in other situations. Hook up the tower with a circuit wire, and temperature plus fuel information can be used for controlling inserters that feed combustibles into it, very similar to the fission reactor. Anyway, since I'm already on the topic, let me further elaborate over more space-age exclusive buildings which can be wired to the circuit network, starting with the rocket silo, the cargo landing pad, and its counterpart, the space platform hub. The landing pad is basically a larger version of the requester chest, with the difference being that it only requests items from orbiting space platforms. If you just want to know what's currently inside the inventory, use the read contents function. But I assume that many are going to be using the set requests mode to get the most mileage out of it. Connected circuit networks are now able to tell the building what items it should ask the platforms for. This can be useful when you have a separate storage on the planetary surface, but still want to dynamically get missing items from platforms. If you are looking for the reverse, namely requested items from all space platforms, the rocket silo's got you covered. It has the ability to send out all unsatisfied logistic requests from platforms orbiting around its celestial body. Very handy when you want to ship in missing parts or buildings from a mall by request. Speaking of orbit, the heart and centerpiece of every space platform is its hub. Bespoke hub can be wired to the circuit network and provide every engineer with a variety of useful functions. First one being the standard read contents option, where the container just sends out all stored items as signals. A bit more interesting is option number 2, send to platform, where signals coming from external sources can now be used for wait conditions and station interrupts. When a space platform fires up all thrusters to venture out into deep space, these remaining options become useful for making decisions about the vessel's state. Details on the current route, namely origin and destination, can be retrieved with these two options. Side note, to tell them apart, which planetary signal is which, the devs made it so that the origin always has an attached value of 1 and the destination an attached value of 2. We can use a combinator to separate both if so desired. Other available telemetry data can be provided by enabling the last two options. Both speed in kilometers per hour and total sustained damage in, if I'm correct, total lost HP of all constructables are able to elevate controls and risk minimization. One example would be a mechanism that throttles down platform speed in relation to taken damage on its route. Reducing overall speed will give defending turrets and asteroid collectors more time to do their job. As a small tangent, before-mentioned buildings can also be wired to a circuit network to control details on their job using signals. Turrets can be passed a list of entity targets and target priority they should shoot at. Asteroid collectors accept a similar list of filters to only collect chunks specified by circuit logic. Both are able to send out stored ammunition or gathered space debris too. Speaking in practical terms, this can be used in combination with the hold all bells option to make asteroid collectors only pick up resources that are under the set threshold. For turrets, I'll add a few bits to the previous example that was all about vessel damage. All rocket turrets are currently set up to only shoot at big asteroids. When the platform receives enough damage, a decider combinator will add medium and small asteroids into everyone's target list, so that rocket turrets will help out shooting smaller space debris as well. Alright, I think this space platform is sufficiently outfitted for its next adventure. God damn it. Anyway, this gives me the opportunity to change subject to today's last topic. I honestly didn't think that there was any chance to see it ever in Model's Factorio, but here we are. With update 2.0, the devs introduce gambling to Factorio, time to hit the slots and win huge prizes. Wait, what the hell? That's not part of the script. What I was going to explain is that update 2.0 brought in the ability to set recipes of every crafting entity through a connected circuit network. Tell an assembler to craft solar panels? No problem. Make a chemical plant produce rocket fuel? Sure, why not? Convince a biochamber to turn your makumash into nutrients, then realize that your quick trip back to Norvis made all the fruits go bad, to then add a mechanism that changes the recipe automatically to turn piled up storage into nutrients first, then switch back to the original recipe? Absolutely no issue. Basically, we are at a point where the automation itself can be automated. Now let me show you how to set up such a mechanism in detail. To get started, begin by selecting a building of your choice, place it down and hook it up to a circuit network. Quick notice, here's a look at all potential buildings that one can choose from. Next, when you got your machine ready, open up the interface and check the set recipe option. The physical setup is completed. If we now send an item signal to the machine, like electric mining drills in my example, we can see the assembler switching to the recipe and, if supplied with ingredients, starts crafting such. At a point where I have enough items in storage, I want to remove the current recipe. So I simply stop sending the item signal to the assembler. But what is this? Some ingredients made it into the storage chest somehow. To explain this behavior, let's repeat the process once more while the UI is open. The moment the recipe signal disappears, we can see ingredients and also finished products move to the right. All these remnants of past recipes are now considered output items, meaning extracting inserters will take them out of the machine. That's the reason why some copper plates, steel beams and green circuits landed here. One additional thing to notice, these leftover items inside a crafting entity will prevent switching to a new recipe. The machine has to be emptied out first before it can be useful again. Pretty good so far. We now reach the point where we can tell a crafting entity what stuff to make and it actually doing so. Do not skip on the details, let's talk more about available control options and some important edge cases. Pausing the crafting process can be done with a global enable/disable condition. Doing so can help minimize ingredient item spillage on the output side, since the recipe itself doesn't change when the machine is not operating. Speaking of operation, one more control option is called read working. Very simple to understand. Over the duration of the machine doing stuff, a signal with an attached value of 1 is generated. One example to use that option would be to track the productivity of assembly subsections. These assemblers are in charge of making red circuits. By tracking the current elapsed time it takes and the amount of work in machines per step through this W signal channel, I can read out the overall work in percentage. Technically speaking, this also displays the overall number of machines that currently have insufficient ingredients. To be fair though, there's a much better way to check for all items inside of a machine. These two options here will make it happen. Enabling read contents will output all items in any slot as a corresponding signal. This equally applies for ingredients on the left side and for buffered finished products on the right side. A thing to note, some items which are processed by the machine disappear at crafting start from the left side, hence the signal output decreases as well. Bespoken problem can be circumvented by checking the include in crafting option. Doing so provides a more accurate representation of items inside of a crafting entity and makes overproduction by unstable ingredient information less likely. To track the number of products a machine already made even better, utilizing the read recipe finished option is recommended. Assign it a signal channel and it will output related signal with an attached value of 1 when products finish. While staring at the UI for a bit, I asked myself if this signal channel could be set to a value similar in how the wildcards behave. What I mean is that the machine translates the current recipe information into this signal slot automatically. While running a few tests, it became fairly obvious though that making both channels the same type isn't such a good idea, since outgoing signals now lose information clarity, making it hard to tell what option sent out which value. If still desired, some simple external circuit logic has no problem to replicate my desired feature to give me a single pulse of the just manufactured piece. Anyway, coming back to available control options, one last mechanic remains yet to be talked about. In my opinion, the second most helpful feature, just barely beaten by the set recipe option of course. As you may know, inserters that shove items into the machine are smart enough to know what the facility requires and grab matching items from nearby inventories automatically. This works well enough for small production sites, but orchestrating modular crafting over a larger scale demands for a better way to sum up needed ingredients. A perfect time to introduce the read ingredients option. It works pretty much exactly like its name suggests. Output signals now consist of all raw items that the current recipe requires for the next crafting iteration. Out on the field, mentioned signals can then be used to call for needed materials. While sourcing items by train is also possible, using the logistic network is probably your preferred method for procuring ingredients. Place a requested chest and attach such to the network, and robots will start to carry over supplies and even take away finished products back to storage. If you fancy the idea of that concept, I want to quickly shout out Doc Jade's AutoMall blueprint for a fleshed out solution. A link to their video will be in the card and in the description for anybody interested. With that said, I want to round out this section with some autocrafting edge cases as the final chapter for today. Namely, values for setting recipes and internal priority. As it turns out, signals with negative values cannot be used to set a recipe. In similar fashion, signals of items that the machine cannot make in the first place don't cause a recipe change either. Now, what happens when I have a recipe set and add a second signal to it? Two actions can happen. Number 1, the crafting entity ignores the new signal and sticks to the existing recipe. Number 2, the crafting entity realizes that the new signal is of higher priority, forgets the initial recipe and changes to the new one. By adding even more signals as input parameters, various priorities can be observed. The signal steam engine can overpower the signal for iron gear wheel. The signal wooden chest is of higher priority than the signal express transport belt. Blue science beats utility science but gets overpowered by green science, which is overtaken by red science. Also, yellow ammo has priority over red and nuclear ammo but is swapped out for combat shotgun the moment such enters the realm of the network. Finally, when I cherry pick one signal from those examples, we see that red science overrules combat shotgun but is beaten by steam engine, which ultimately gets pushed aside to make room for the almighty king, the wooden chest. Well, who would have guessed that a cube-shaped board box is considered of highest priority? I certainly didn't. Supported by this experimentation, I am pretty sure that the general rule of priority lies in the relative location of signals inside of the interface. When looking at one row, signals on the left will be more influential in comparison to signals on the right. For signals coming from different rows, a given priority relies on the vertical arrangement, where signals on the top have more priority than the signals on the bottom. Lastly, when signals are located in separate categories, similar left takes priority over right functionality applies here as well. Small side note, a network visualizer such as the signal display on a power pole can be helpful for getting to know the current sorting order, under the condition that all channels must have the same number. It will then rearrange the network content so that the top left slot will represent the signal with strongest influence/priority. Identifying the chosen recipe for valid crafting entities becomes a piece of cake with this. No memorizing any rules needed. And there we have it. While including our topics from the first part, those are all the major changes and new additions to circuitry after the 2.0 update that I wanted to talk about. Hi, Pivot editing the video here. Once again, Factorio devs thrown a wrench into the works with minor update 2.0.67, where splitters can now be controlled by the circuit network. Thanks, Wob. Since I decided against rewriting today's script to make it fit, I'm now stuck between waiting until the next major changes to add it there, or perhaps putting it in a shorts type video to get it out faster, despite not liking upright video formats too much. Maybe you in the comments can let me know whichever solution you would prefer. Anyway, I'm handing the mic back to pass me with the final words. While it's very much possible to beat the entire game without ever placing down a single combinator, having the ability to balance underlying production through carefully crafted logic and solve situational problems with brainpower rather than brute force makes it that much more rewarding. At least that's my personal opinion on it. Thank you so much for watching, and until next time, peace.